Uh, uh, yeah. We are actually trained to look at things in 3 dimensions. Okay, we have psychologically, and that's how we are built. Actually, we have difficulties in understanding 2 dimension. It is easy for us to understand things in 3 dimension. Okay, and that's the underlining concept. Now, if you take that and apply for city planning, in city planning, it is not an easy. For example, let's say I prepare a plan and it's implemented. It's not like that. There's no I here, and it's a group of maybe hundreds of people are involved in preparation of this master plan. Okay, and at the end, at least now in Indian context, we have decision makers who are not technically sound. Okay, many a times it is a politician who doesn't know ABCD of what is plan and what is this that. Okay, and many a times he will be the one who will take decisions. Okay, so as a technical person, we ourselves have difficulty in understanding 2 dimension. How a non-technical person will have understanding of a complex city planning exercise. Okay, so in that perspective, there are many works have been done on how we use 3D in city planning. Okay, so and you must have seen in most of the cases it is restricted to visualization. We visualize things. Okay, even in my presentation I showed in the first slide itself a 3-dimensional layout. Okay, we use we use 3D for only visualization, but apart from visualization, navigation, that's there in the Google map as well, right? So apart from that, how we can use this 3D for scientific decision making is something which has been which is of my interest, and there are many studies being done in this area as well. I'm just going to show you one example, some examples taken from very quickly from literature, and some of the work that I've done through during my research work, and also in collaborating with other experts as well. We use 3D for visibility analysis. Okay, for example, let's say, I think when I say visibility analysis, those who have used GIS, they can quickly relate that there is a tool called we can do this analysis, right? Visual analysis in GIS platform. Okay, where do we use it? We know it is there. There is a tool called visual analysis. Where do we use it? How do we use it is the question. We use this, for example, in this work, they have demonstrated how this can be used for appropriate location of, let's say, hotels, appropriate location of a specific store, appropriate location of specific landmark. Okay, and what is the visibility of it? Okay, that kind of interventions can be done. Of course, flood modeling, I think many of you are already aware. Flood modeling is something which many of the engineering students they take up as a research work, and then develop certain models, 2D, 3D, all that. Okay, and this is one way it can be done. Of course, we do this as well. We do this in planning as well. For example, one of my doctoral student, she is developing a model on how change in topography increases urban floods. Okay, so we are trying to use 3D GIS for that, to understand how we have first of all altered the topography, and how, because of altered topography, okay, which, let's say, for example, this is natural topography, and we have made something like this for our convenience, for building, for making buildings, right? So how this alteration has impacted urban floods? How do we quantify that? Does urban flooding model considers this alteration or not, is all the questions that we are trying to understand. Then, of course, we do use for noise planning as well at city scale, to map out which area is 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 within the permissible level or not. All that we do. It is applied 3D GIS applied for that. And for example, let's say solar energy potentials. This is one of the topic that we do in our studios as well. Many of our students we do this kind of exercise where we try to identify the potential locations for solar rooftops and so on and so forth, and this is one way 3D GIS can be applied. Okay, these are from theory. Apart from that, there are many ways in which 3D GIS can be applied. Okay, I'm not going to discuss all that, but I would like to tell you one thing which I had done during my research work. Okay, during my doctoral thesis, how I use 3D as one of the tool for simplifying the decision making. Okay, so very quickly, and then we'll move further. I have used a word called volumetric analysis, which means it's actually taken from chemistry. So, for example, let's say if we introduce one element in a given environment, okay, and there are already existing elements there, right? So, what is the impact of introducing this element on the other elements? Okay, so it's as simple as that. So if you introduce something into an entity, that introduction of that element will have an impact on other entities as well. Okay, what is that, and what is the kind of reaction that takes place between the new element and the existing element is called volumetric analysis. Okay, and the same things apply, the same similar idea applies for city planning as well. For example, let's say we have an existing city, and let's say we already have certain developments in place. We have habitation, let's say this is some natural stream, and we have some green buffer areas and so on and so forth. And let's say if we introduce an industry here, okay, so we are actually introducing a new entity to the existing environment. And how this relationship works? Okay, what is the impact this entity will create? It will have an impact on other entities there. Okay, that's the kind of relationship that we can study, and that's what is being done here as well. And like I said, 2D has always been an issue. Looking city in 2 dimensions has always been issue, and from the literatures we can it's been proven time and again that we visualize things in 3 dimensions. So we need to have tools, simplified tools, not complex, very high-end running machines for doing this kind of work. Okay, simplified method for generating 3-dimensional cities is required, and it's been there for quite some time now. And in my research work as well, I was just trying to say how this 3D city model can help in designers specifically for decision making. Okay, in specific decision making is what I was trying to do. So again, the case was in Chennai. This is a part of Velichery. Okay, this is one stretch. What we did again, of course these things probably you know. Let's say if we have the map, if we have mapped this particular area, and we need certain planning informations and building information. Planning information in the sense, for example, what is the FSI, what is the plot coverage, what is the maximum building height that we can build there, setbacks required, what is the abutting road, and so on and so forth. Building level information, we need to know what is the kind of use, number of floors, inhabitants there, so on and so forth. Okay, the more number of parameters that we can add depending on the kind of analysis we do, of course we can take to we can discuss different problems and find out specific solutions for that. Okay, so in this case what I have done is, what we try to do is primarily map the kind of uses, whether it is mixed use, primary residential, commercial, so on and so forth. as far as the land parcel is concerned. Building parcel is concerned, we did do primary survey of all the buildings there. We were trying to map all the activities that is happening within the building as well. Okay, so this we did. Then what kind of analysis can be done if we do this mapping? Here I said the more number of parameters that we add, a lot of analysis can be done. What analysis can be done? For example, let's say we are interested in knowing what is the building use across the mapped area. We are interested in knowing how the diversity of the building use varies within that region. We want to know how what is the density variations in the locality. Okay, do we have information on floor wise? Floor wise does activity changes? For example, we actually call we say something called sections. Okay, so if we cut across, let's say this is let's say this is the city profile very quickly. Okay, and we say sections. Let's say if we draw a section line here, let's say this is residential, this is commercial, this is an apartment again, or let's say this is a hospital building, so on and so forth. So if you do an activity mapping at this level, let's say this is floor level 1. Okay, let's say what is happening at 10 meters level from ground. Okay, if you do activity mapping, okay, let's say we have here 1 2 3 4 5 6 7. Okay, let's say 1 2 7. I'm just trying to map the activity here. So we have residential and we have commercial activity happening here. We have beds here, we have, let's say, greeneries here, and so on and so forth. We are also interested in knowing what kind of activities happen there, so that we can plan out certain amenities for that particular layout, okay, for that particular settlement. Of course, we can do assessment of how much parking area is required, so on and so forth. We do some analysis on whether the surface to volume ratio of the building is okay or not okay. What do you mean by okay or not okay? There is a thumb rule for making the buildings energy efficient. Okay, and I won't say energy efficient, slightly better performing than conventional building. Okay, so we use a thumb rule called surface to volume ratio. And we have some thumb rules. Okay, your surface volume ratio is closer to 1, it is better. If it is away, it is not better. Okay, so this kind of assessment can be done. Solid waste generation, where it is occurring and how much it is occurring, all that can be done. And in fact, we can do all the network analysis that is possible within the layout. Okay, yeah, within the layout. Yeah, I'm just going to show you one example of water supply in here. This is again all the housing, all the buildings and the building uses are mapped. Okay, and those who know little bit on how water supply layout is prepared, okay, they have something called zones. It's not one water line and all is not connected like this, right? There is a way in which it is done. They first zone it. Okay, for example, let's say this is the pumping station and let's say this is terminal station, and the pipelines are not just given like this. First they create zones, zone 1, zone 2, zone 3, zone 4, and the intensity of velocity of water is calculated for specific zones, and accordingly the size of the sewer lines are determined, and then connections are given. Okay, so how is it related to planning? Let's say we have mapped this and we have also generated results, how things work. If we see, we use something called FSI, floor space index. Okay, and let us say it's actually a theoretical approach. It's actually a pilot study that was done to check whether the model that we were trying to develop is actually working or not. We planned this particular layout for specific development, specific intensity of development. Okay, let's say if you just put that into perspective, let's say 1.5 FSI. What is FSI? Let's say you have a plot of 100 square meters. You can build 150 square meter building there. 1.5 times of your site area can be built as building. In very simple definition, if you have to take it further. So and the entire layout is planned like that. Okay, whatever land parcels you have, at the max what you can do is you can build 1.5 times of your site. But in reality, does that same thing happen or not is one question. Second is, okay, in reality, maybe let us say instead of building 1.5, we may build 2 times. We may violate. Okay, I'll also show you how it works. We may violate and probably instead of building 2 floors, we build 3 floors. Okay, but what happens to the city in that case? There is something called carrying capacity. So this plot where you are supposed to build only 2 floors, we have built 3 floors now. So what is the big deal? The big deal is the infrastructure that is placed here is not designed for 3 buildings. It is designed only for 2 buildings. Okay, so it is overall the infrastructure is designed for only 1.5 FSI. Whereas if we keep violating this, if we just abruptly do things, we will have issues of water supply, we will have issues of waste water coming in, water logging, all that issues will come into picture. For example, let's say the same thing theoretically, if we increase FSI from 1.5 to 2.5, okay, that means instead of building 1.5 times, you build 2.5 times what is allowed. So what in the first instance itself we saw that certain areas fail, certain infrastructure fails just by increasing the FSI from 1.5 to 2.5. Okay, so if you go further, for example, let's say FSI 4, most of the infrastructure that here specifically only water supply is failing because the layout or the system is not designed for 4 infrastructure. The system is designed only for 1.5 infrastructure. Okay, so this kind of analysis can be this kind of 3-dimensional analysis will help in understanding how carrying capacity will have an impact if we change FSI, so on and so forth, can be done using 3D GIS. I'll just show you a little more example on the same thing. This is for one state. We did that exercise for a little longer. This is Kannadasan Nagar, part of T Nagar. Those who know from Chennai, you all probably will know. And again, like I said, first thing we do is we do mapping of that particular area. Whatever study area we do, we just do mapping. When we say mapping, we do mapping of the layout, land parcel. We do mapping of the building footprint as well. We do mapping of the land uses, building uses, number of floors, so on and so forth. I think I have the list to show as well. Okay, so this is part of T Nagar, 2D, 2-dimensional drawing, and you can see that we were trying to map which are residential, commercial, institutional, open space area in terms of building. This is building use, okay, specifically building use. And of course 3-dimensionally, what is the total volume of building that is there, okay, in terms of residential, commercials, and so on and so forth. And the same idea that I showed here, if we just take one service and check whether this intensity of development, what is the carrying capacity of this infrastructure that is placed here for the building that is designed. Okay, so we did we did the primary survey, and we have mapped all the drainage pattern, size of the drainage pattern, where is the pumping station, how much water is pumped and how it works, all that we were able to model. and then we created scenarios now. And before we go further, I don't know whether I have the slides for that or not. Maybe I can give you an idea. This is those who are from Chennai. They know that initially T Nagar was not planned for commercial activity. It was actually planned for residential activities. Okay, it was planned in 1970s, and it was only residential layout. Okay, I think I don't have the layout. Otherwise, it was planned as a residential layout where we have a lot of commercial activities in place. Lot of commercial activities primarily in the main main roads that is connecting the parcel, and in fact you can also see multi-use buildings that is coming inside the residential areas as well. Okay, so and also these infrastructure that was done by the Britishers. It was so far as on date I speak, this has not been improved. Okay, and a lot of work, lot of initiatives were taken to map it, and they said there will be an enhancement of this infrastructure, but I don't think it is done as on date as well. So we are depending on an infrastructure which is created in 1970s, and that too made for residential layout. Now we are building 1.5 FSI, 2 FSI, so on and so forth. Okay, and in many times I have in my study I was able to identify which part of the area will have issues related to water supply, related to carrying capacity, so on and so forth. Again, here I use a three-dimensional analysis for showing that. For example, this is one such layout. So if we just increase, this is all buildings, floor-wise information is taken, and if we just increase the FSI, okay, sorry, not increase the FSI. This is existing status that was in 2013. Let us assume that the entire city or the entire layout is actually made for 1.5, which is allowable in that particular layout. Even for 1.5 FSI, most of these buildings will not get water. In specific, if I have to say. Why? Because we don't have the infrastructure that is there to supply this much amount of water as well. So that's why if you see the master plan, they must have put 40 LPCD. 40 LPCD of water is supplied. What is recommended? Recommended is 135 LPCD is recommended, whereas master plan they say we have achieved 40 LPCD, and in reality we have taken primary survey of almost all the buildings, and we were able to calculate that it's around 20 LPCD is what the people get there. Okay, why this happens is because we don't have infrastructure in place. We just keep building, we don't realize. Okay, that's why I said planning is multi-dimension. Okay, there are many people are involved in it, and finally decision maker is some XYZ. So if we use a tool like this, which can communicate, which can help the decision maker in a better way, these tools can be used. And in fact we use this kind of experimental work as well for highlighting these kind of issues. For example, let us say another 3D application that we can look into, as per master plan of Chennai. Okay, I think I'm already running short of time. Anyway, fine. Already if you see the development plan for Chennai, it says we can build 3 types of building in most part of the Chennai. One is called ordinary buildings, second is called special buildings, multi-storied building. Ordinary buildings less than 2 floors, special building still plus 4, and anything above still plus 4 is termed as multi-storied building. Okay, and if you just apply the rules into this layout, okay, if you just apply this rules into this layout, what we'll be able to do is these plots that you see as blue can be built as special buildings, and the red ones are supposed to be plot areas where we can do multi-storied building, and all other is meant only for residential purpose. Okay, this is as per if we strictly follow the rules. But we did a study in 2013, and this is as per the rule, and this is what is existing there. Okay, and you can see that these are actually roads which is just 6 meters wide, not even two-way line. Okay, first two-way we said 7.2, right? Even we have lanes which is just 6 meters, and we have multi-storied building there. Okay, we have multi-storied building. In fact, now I don't know if we do assessment, probably this all should be red. This is still 10 years old data now, almost 10 years old data, right? So we use GIS to for simple applications like this as well. Okay, those are actually some of the work that I had done during my research work. Now we apply this in these studios, and we have applied these ideas into other forms as well, which I'll just quickly run through. Some of it maybe which will give you an idea that how we as such, let's say architects, planners, landscape architects, and so on and so forth, who are primarily architects. The base is architects. Architecture is the base, and how do we use GIS for our studies? One, I have put from recent to old data. Okay, just to that's how I had done it. So excuse me for that. Okay, so recently we did a study on how population and density do they have a relationship on the spread of COVID, and so on and so forth. Okay, and I think these are all very simple things for you. How do we take census data and then club it to the geospatial the database of India map? Here I have used district boundary map of India to show this. Okay, and of course a number of cases and all. Of course you know how to use this, how to relate this. We use a similar technique. What is the difference between how we take these results into planning applications? We are interested in knowing, let's say, whether high dense area or low dense area have an impact on spread of COVID, and so on and so forth. Whether there is a relationship between built high dense populated areas versus others, and so on and so forth. And by the way, this is for first wave. Okay, and it took so much time for publication that now we have third wave. Okay, and maybe it's other work is in progress for second and third put together, and we'll see how this is, whether this result is meaningful or not. Also, we don't know. We will get to know once we superimpose the other informations in this. Okay, that's one of the application. Another application we did on informal settlements and workplace dynamics. Is there a relationship between how informal settlements, like for example slums or low income housing colonies and the workplace? Okay, the blue areas that you see is commercial, and the red ones are the areas which are actually slums or low income housing settlement. What is the spatial dynamics between these two? Whether they are appropriately positioned or not, whether the city has taken care of the connectivity for this is one of the studies that we do to understand the dynamics between this kind of movement. Of course, this can be studied for other purpose as well. Here specifically we have studied for low income settlements and the workplace dynamics. And of course, all these things probably just by looking at the results you will be able to understand how buffer tools can be used for this, and also the other line of sight analysis, just to know what is the intensity of connection, which is weak connection, which is strong connection, so on and so forth. Okay, how does it matter for planners? It matters for planners because we will be because at the end of the day we will say that okay, this area is marked for low intensity development. We need to have connecting corridors like this. All that we do take decisions on. Okay, and whether this decision is appropriate or not, this kind of studies will is useful, and we do use this kind of understanding on developing layouts. And of course we do, in the beginning I said land surface temperature. Okay, this is one of the topic that we many of the architects and planners use to know what is the impact of greenery that is created. Okay, is there an impact of greenery that is created in the large context? Let's say in the large scale, let's say sea. Okay, so for example, let's say if you take Tamil Nadu or Chennai and then do LST, the sea will have, of course, higher temperatures, right? You must have realized. So if we look at the land surface from the large perspective, water bodies are not ideal for ideal as a cooling entity, whereas in the smaller parcel, let's say if the same, let's say this is water body. Okay, this will have a positive impact on the city than a large water body like, let's say, sea. Okay, which may sometime counter the issue. In fact, it will create more problems as well. Yes, more problems as well. Okay, so one of the study we did this is done in Dubai. One of the layout was evaluated for greeneries and its impact on the layout. And we did a similar study for Amaravati city. Okay, proposed Amaravati city. You all must be aware. Andhra Pradesh. They had an idea of creating a new city for newly formed Andhra Pradesh. This is Vijayawada. Okay, and even in this case, the intention of our study was to identify how useful these greeneries and blues will be for the city. Okay, here we have just mapped only the greeneries and the water bodies created in this master plans, in the master plan, and we wanted to check whether these greeneries and the water bodies that is there, that is deliberately created, will make a difference or not for the kind of development that we have here. Okay, so that's one of the study that we are very much interested in. Many of the landscape students as well take up this kind of study for coming out with some meaningful solutions. Okay, so this is how we use land surface temperature, not just from giving an overview of urban heat islands, but we are actually specifically looking for, let's say this is a blown up results. There is a canal here. Okay, and this shows how much cooling intensity that we can extract because of this particular canal for that particular time period. Okay, so this is whether having only blue will work, or do we have to add green to that. All that we try to experiment, and then we make use of it. And then this is another different study where again we use GIS for identification of trailing routes for bicycle trailing route. In fact, this is one of the studies that is done in the hilly regions, and is quite often you will find papers on how do we come out with trails, biking trails for the layout, and this is one of the study done by students, and we converted that into research paper later on. And here again, what is the primary data used is the topography, okay, and which what is the ideal steep for biking, and which is useful, which is not useful, all that can be done, okay. And this is one of the study done, and this is that all that what I have shown is all probably at a broader scale. There was one of my PhD scholar, and she's happened to be faculty here, and I think she's there in the session as well, Dr. Banu Chitra. She worked on how sound can be mapped in an urban area, or not an urban area, in a park. Let's say this is I think this is Chennai, one of the parks in Chennai, and some case studies in Vijayawada, and one of the case studies in Delhi. The idea was again, how do we map sound? Okay, in the initial slide I showed noise mapping at city level. Okay, this is broader scale, and she did a smaller similar approach in a smaller scale on understanding how sound can be mapped. Okay, so here again we use GIS to extrapolate. Okay, there are many steps are involved in arriving at how the sound levels are mapped. Just to give one indicator, for example, let's say you take continuous measurement, okay, at a specific location, and that location, that trail is all defined in the research problem. There is a way in which the sound work can be done, how sound can be mapped. But where is the application of GIS here? How do we use GIS? I think in the one of the tools that is there in GIS is called interpolation, spatial interpolation, right? So spatial interpolation can be used to interpolate, not in this case we have used sound, okay. So we have measurement for a specific location, okay, and we wanted to know how the sound is spread across the paths, okay, and how it can be mapped. And later, let's say if we introduce a landscape element here, does that have an impact on the sound quality there or not? Okay, so this is one way of looking at it. There are other ways of looking at it as well. For example, let's say if we are talking only about heat can also be mapped in the same way and then studied as well. Okay, these are other examples from the same study offered. Recently, we did one project funded by European Union where we did an assessment of the impact of same thing, the green and blues on green, blues and building density. What is the relationship and how it interacts and so on and so forth, what we can do for Bangalore city as well. Okay, and this is another study, we did in 2015 based on 2015 Chennai flood. We of course all this thing probably you know, I guess, how do we extract 2D built up area, superimposing with indented area. Okay, what is the outcome for planners? What kind of outcomes can be derived for planners? So for example, let us say this is actually existing water body that we were able to identify in 2013. This is not 13, sorry, 15. Okay, this line that you see is actually taken from a master plan prepared in 1972, 1970s. I don't remember exact date, the year. 1970s we had a master plan. If you take up the master plan and digitize it, the boundary of the water body is something like this. Okay, and of course this applies for all the water bodies that is there. In fact, if you can read the papers available. We found that from 250 plus square kilometer of water body has shrunken to just 50 square kilometers of water body less than 50 square kilometers of water body in 2015 when we did the assessment. Okay, so by default or by any logic, these reduction in water bodies which are supposed to carry store the water and no longer is there, and this is bound to create problems for us, right? So this helps in identifying areas which are safe zones for city, okay, which areas require some kind of intervention in terms of planning. All that we try to identify when we say that these are vulnerable, non-vulnerable, and so on and so forth. Okay, that's a broad view I've given on what is the kind of applications that we do in 3D and current research work as well. Now currently, which I'm also reading a lot, and also I'm encouraging the students here and research scholars here as well, is on how do we relate this with the climate. Okay, that's what we are just trying to understand. So for example, let's say when we talk about a city, we do talk about urban heat islands, okay, and everybody is aware of what is urban heat island. This is one of the study, one of the output that is done using GIS. Okay, that's a broad scale. Now that the same thing can also be applied in a smaller scale as well. For example, architects primarily work at building level, right? So we don't do UHI quantification at building level. But now architects do work at street level, street canyons, okay, a group of buildings, so on and so forth, or block level or neighborhood level. Okay, all this scale we do we do some work now, and we always encourage that we should not just look at the building, we should look at outside and see what is the kind of interaction that we have. Of course, at the city level, a lot of work has been already done. So here again we can use GIS. Where is the component of GIS? So for example, let us say I was just talking only about what is the impact of greenery on city, what is the impact of blue on city. Okay, we also have we know by your understanding of urban physics that building also store heat, right? These are actually kind of a storage places for heat, right? Buildings store heat. So that's why we have higher temperatures in the night, because it sheds out heat. So what is the energy balance between building, greenery and blue? This dynamic has to be understood, and this is something which we quite often I personally encourage that we should work at this scale. Here again we can use GIS for that, and this is one tool that we use in in the urban studies. For example, let's say I want to know how much sky is visible for me in this particular layout. Okay, for example, at building we do talk about shading, right? Do we have sunshade? How much is the sunshade? We use a similar analogy in urban level as well. We ask how much sky is visible. Okay, is that visibility is good, bad, all that we can do. Okay, so we use Rayman and Sky Helios, and for that the base map is of course we need to have a base map, and that we go back to GIS again for creating that, and we superimpose we bring in climate data into this to make certain decisions on that. And of course there's something called outdoor comfort we study using this particular tool, and I think this requires no explanation, because many of you must have done. UHI is something which is commonly done by planners, by GIS expert. Everybody who knows how to calculate LST, they end up publishing paper on UHI. Okay, so that's how it is. And apart from that, we can study. We can use GIS for various studies. Okay, on how the introduction of green can have an impact on UHI. Okay, that's something that we do, and we use GIS for that. Okay, and of course we do use GIS for modeling urban energy as well. For example, let's say at building level we do energy assessment. We calculate, okay, this particular building consumes 20 kilowatt hour per meter square of energy. But what about the entire, let's say, entire city? Okay, we do an abstraction of the city. It's called archetype. Okay, this is specifically, the word has been specifically developed by the building energy experts and so on and so forth. And what we do is, I'll show you. I'll show this and then come back to this. I think you must have seen the same image I showed you some time back. This is part of T Nagar. Okay, I had that base. Now I wanted to do an assessment of what is the total energy consumed by this particular layout. Okay, I already have information, individual building level information. I just wanted to know how which building is performing, what is the energy consumption of individual building unit, and so on and so forth. It is not possible for us to do individual building models. What do? Is we apply a technique called archetype, where we take a sample. Okay, where we not sample, we actually do a characterization of, let's say this is all residential area, and this has got let's say 200 buildings. We don't model 200 buildings. We do a characterization in terms of building height, building volume, kind of use, and so on and so forth. And through that process, we reduce this 200 to, let's say, some 10 or 20 buildings. So this 10-20 buildings will be modeled. Energy assessment will be done for that, like this. For example, let's say this is a typical representative of residential buildings in this particular layout, and typical representation of commercial buildings in this layout, mixed use, and so on and so forth. And of course, all the other informations are required, how much energy is used, and so on and so forth. And we'll be able to generate, again, using GIS only, what is the energy consumption, and so on and so forth. And in fact, adding another column, we will also be, if we just add solar radiation and effective roof area, we'll be able to calculate what is the solar energy potentials available for that particular parcel as well. All that we can do. We do that, and of course we have something called urban weather generator. Here again we use GIS base for energy modeling and other studies as well. Okay, in summary, what I want to say is, building for understanding building, we simplify it in terms of how the windows are made, how the walls are made, how the roofs are made, how the shading elements are made, and how it is placed on earth. Okay, so envelope, material, thermal mass, shading is what this is how we look at the building. And the same thing we do at urban scale also. Okay, so for example, let's say this is the city section. Okay, building city section. Same analogy is used here, but the scale is slightly different. How this building is interacting with the greeneries, how this building is interacting with the other buildings, how this building is interacting with the water bodies, and so on and so forth, and what is the amount of sky visible, what is the wind condition, so on and so forth. All that we do, all the building physics level analysis we try to do at the we try to extrapolate the similar understanding on an urban scale as well. Okay, why I have said this is, the common platform for doing this is GIS. We use extensively GIS. For example, these things I showed in the beginning: building use, building geometry, let's say size of the building, floor area, all that we were mapping from the first slide itself, right? So what is the additional thing that we have added to that list, to that attribute information, is temperature information. Okay, in terms of air temperature, heating degree days, or or let's say, let's forget heating degree days because we may not understand. Let's say air temperature, wind directions, wind speed, relative humidity, and so on and so forth. And we do some, we extract, what do you call, we extract certain information from the base model, which are useful for urban studies, which includes how much sky is visible, what is the building density, what is the front area ratio, all that. The extraction is done in the GIS platform itself to understand what is the relationship between building and climate. Okay, this is what something I'm just trying to promote and also encourage students here to do work on. Okay, so that's in summary on how we use GIS. Okay, starting from mapping to mapping layout to mapping regional level issues, and specifically addressing urban issues in terms of like how residential layouts are placed, what is the connectivity, or flooding, or about sound, or about the impact of greenery and blue in the city, so on and so forth is studied, all again using GIS. And now not everybody is focused. I'm interested in that, so I'm just highlighting that climate is also can be integrated for sure into this, and a lot of studies can be done together. Okay, thank you. That's all I have to say from my side. And if there are some questions, I will be happy to take.
Thank you, sir. Sir, will it be possible to share the PPT, sir?
Yeah, sure.
Yeah, yes, sir. Thank you, sir.
On behalf of SGE, I thank you for choosing to speak at our webinar this evening, sir.
Thank you so much. Thank you for inviting me.
Your readiness to share your experience and expertise on the topic of application of 2D and 3D GIS in urban planning and design has been nothing but extraordinary. I'm sure that everyone present at the event learned a great deal through your talk, sir. And I hope that being a part of your webinar was a positive experience for you as well. Being an expert in your field and to have you as a guest speaker was the best thing we could have done to inspire ourselves. Surely, I believe that your bright ideas and guidance had a great positive impact on our attendees. And once again, thank you on the behalf of everyone present here for your kind gesture towards our institution, sir.
Thank you so much. Thank you for inviting me. I hope I've conveyed something that you can take it further. And probably you may have got some idea on how we use GIS. It's all only applications, primarily. Thank you so much. Thank you. I think.
Thank you, sir. Thank you, sir.
Yeah.